All right, so tables, I'm going to put the emphasis on tables of lines also show us the rate of change. So let's look at the first table that's on your sheet. So when I look at this table, I'm going, this is interesting. I'm going to look at the X part. Now the X part of a table, these are the input numbers. So let's remind ourselves that X is the input. That means we can put anything in for X, but our answer is the output, which is the Y part of the table, right? So we can see that our input is going by ones. We're going down 0, 1, 2, 3, 4. Well, that's boring. But our output is doing something totally different. Our output is, okay, so I had to pause for a second there. So I guess I was talking about output. And as I look at this output, this is where the action is, right? The numbers are going 5, 7, 9, 11, 13. What's going on with our output? To go from 5 to 7, that's right, we're adding 2. 7 to 9, we're adding 2. 9 to 11, adding 2. 11 to 13, adding 2. So our rate of change with each thing as we're working down the table, right, we're going up by 2s. That's one way to look at it. Just look at the table, see, notice the patterns and how the patterns are changing, and then decide, well, it's positive, so it's increasing. Okay, so that's one way to do it. Let's see what I have underneath here. Look at the Y column to see if the table is increasing or decreasing. Okay, that makes sense. Or you can look at your rate of change. If it's positive, it's increasing. If it's negative, it's decreasing. Okay, let's look at this next one. So with this next one, once again, the input is boring. We're just going up by ones. 0, 1, 2, 3, 4. It's the output that tells you what's going on with this linear equation. So we're going 9, 5, 1, -3, -7. It's kind of a little bit harder to see what's going on when we have the negative numbers. But look up here. What do we do? How do we get from 9 to 5? Well, we lost 4, didn't we? So 9 minus 4 is 5. 5 minus 4 is 1. 1 minus 4 is -3. -3 minus 4, if you picked up your calculator right, would be -7. So when we talk about rate of change, we're talking about what's changing with the pattern as we move down the Y column. Rate of change with tables, we look at the Y column and we see what is changing with the pattern, or what is the pattern as each number's changing as we're moving down the Y values. So we just said we're moving down by 4, and that's decreasing. Now, I do want to give you a second way to do this, because sometimes people are really great with patterns. They just see them right away, and they're done. Other people actually need a method. So actually, we're going to do that in the next one. I'm going to show you the method. Oh, no, I guess I'm going to show you this one because it says we always start our hoops from the bottom and go up. And you're just going to say, Miss Overby, what are hoops? All right, here we go with hoops. So with hoops, it's another way to figure out the pattern instead of just staring at it. So with hoops, what we would do is we'd start at the bottom. We'd say -7 minus -3. And I know what you're saying. Yep, that's right. Pick up your calculator. You can do it in your head if you want, but pick up your calculator. -7 minus -3 gives me a -4. Right? -3 minus 1, if I did that in my calculator, is -4. 1 minus 5 is -4, and 5 minus 9 is -4. So I know what you're saying too. It's like, why would we do the hoops when we can just look at it and tell? Some people like having a method. Down the road, we'll also have to pay attention to the X side of the table to get the rate of change. All right, so with this new table, we notice that once again, X is boring. It's just moving 0, 1, 2, 3, 4. The action's with the Y, and we're like, what is going on here? 5, 5, 5, 5, 5. So let's look at the pattern. How are the numbers changing? What do you say? They're not changing. No, they're not, right? They are not changing at all. There's no rate of change. And what's another way to write no rate of change? That's right, just 0. And 0 is neither increasing nor decreasing. It's doing neither. So let's do the hoop so we have a second method. 5 minus 5, 0. 5 minus 5, 0. That's right. That's a second way to find out that the rate of change is 0. That's right. Sometimes we can tell the rate of change from a table without even doing the hoops, and you are welcome to do that anytime. The hoops is just like a backup method to use if you can't tell just by looking. All right, now, oh no, I told you down the road, and here we are down the road already. The X column isn't boring anymore. Can you see that the input, it's not going up by ones. It's going 0, then 5, then 7, then 10, then 15. What this means is now we have to take into account what's going on the X side of the table. Let's go back real quickly to this one over here. The reason why we didn't look at the X side of the table is that if we did the hoops, we'd say 4 minus 3 is 1, 3 minus 2 is 1, 2 minus 1 is 1. There was no change in the X side. But there's change here, so we have to do the hoops on the left side. So 15 minus 10, 5, 10 minus 7, 3, 7 minus 5, 2. Just making sure we're still going. 5 minus 0, 5. Now let's look at the right side at the Y column. Negative 11 minus a negative 6. If you pick up your calculator, you're going to get negative 5. Negative 6 minus a negative 3. Well, that's going to be negative 3. Negative 3 minus negative 1, that's negative 2, and negative 1 minus 4 is negative 5. Now, just a little side note, you will always, always, always be able to use those yellow calculators or any calculator throughout this Algebra 1 course. So please, don't pick it up, use it. All right, so here we go. What are we going to do? We've got a table with hoops on both sides, numbers on both sides, and we're going to remind ourselves that rate of change is rise over run, right? So that's why I'm showing you this. Rise over run is rate of change. Another way to say rise is the change in our y values over the change in our x values. So we're looking at, this is a change in my y value. This is a change in the x value. So the rate of change would be negative 5 over 5. And I know what you're thinking. Well, wait a minute. We also have negative 3 over 3. And you're right, we also have negative 2 over 2. But if you put all of these in a calculator, aren't you going to get the same thing? If I put negative 5 divided by 5 and hit enter, I'm going to get negative 1. Same thing with negative 3 divided by 3. I'm going to get negative 1. The rate of change here is negative 1. Because it's negative, it is decreasing.